And there. Nico. Ah, haionyeshi hiyo live stream. Very fresh. Hakuna onyesha hiyo live stream. Muli. Niko on. Unaniona? Body iko sawa. Leo nafunza QA. Linear programming. Na hii kitu coverage yake iko kubwa aje. Nataka ifocus tu kwa nini? Kwa board. Niweke portrait. Hapo. So portrait iko sawa? Si nita cancel ni schedule lingine. Alafu delete video. So ta edit hiyo video. Sawa, ambia wakuje live. Moja ndiye na watch, wewe ndio na watch. Kwa yako juu uko kwa account yangu. Inakuaje inaonyesha ati moja ndiye kwa live. Okay. Boda itaonekana vizuri. Wow. Ina reflect. Hapo. Bado kuna light. Sawa. Those are the maximum. Hapo imefungwa. Maybe I can just extend this. Hapo nimezishikanisha. Tripod sijaweka on. So niwashe tripod. Ya nini? Mbona hii inakata? Sijawasha stima. Sasa hiyo ring light. Si tutakaa dark. Hapo. Nikizima nini itakaje? Hapo. Okay. Wow. So nini zangu hazikucharge bwana. Microphones. Haina reflection light. I mean sound. Sawa. Sawa. Utasoma na YouTube au utasoma na physical?
Mimi soma na physical. Class imeisha saa ngapi?
I don't know. Shut up. Okay. Yes. So niendelee tu. Sawa. Mzee hapa. Utatumia.
Yes. Yeah.
Uko na earphone Mose?
Sasa.
Unatumia hii for the time being.
Hadi kuna bidii.
Oh, sawa. Okay. So welcome back. This is linear programming sessions. I want to introduce it a little bit briefly before we embark on the other things. I instructed you students to come with the graph book, so I believe you guys have your graph books. But linear programming, as it's stated, linear programming. So the word linear means it's a straight line, something that involves variables. So linear programming. Now, we know that if I, by definition of linear programming, those who are taking short notes, those who are not taking short notes, you can also listen, say that linear programming is a mathematical technique used for solving problems that will maximize profits or minimize cost, as well as optimal allocation of scarce resources. So you find that you want to program yourself on what you want or what you need, and you end up like you don't have enough resources to do it. So you can apply linear programming where you look at the issue of constraints. So requirements for a linear programming to be a linear programming problem, or to be an LPP. The first requirement is that the problem must be capable of being stated in numeric form. In other words, if they involve figures, you must ensure that you convert them into, even qualitative, they must be in quantitative form. Two, they say that all factors in the problem must have mathematical relationship. So they must be linear. Those factors in LPP must be linear, and then also those problems must permit a choice or choices between alternative courses of action. So you find that you can decide to choose one and leave the other. So there must be multiple choices, and also must be one or more restrictions. There must be one or more restrictions. So like a scarce resource has a restriction. You may want to purchase something, but your pocket is limited, so you are restricted. There are those that you can't go beyond, so you restrict those LPP problems. And again, then steps involved in setting up linear programming problem. So there are those steps that you must take into place. One is that a linear programming problem can be constructed and solved to determine the best course of action within the restriction. So number one, the first problem is define the decision variable. The first step, you define decision variable. And then B, formulating objective function. And C, establishing constraint. So then putting in a negativity. So the first is you define decision variables. Define decision variables. Decision variables. And then you formulate, number two, formulate objective function. Objective function. And then establishing constraint. Establishing constraints. So constraints are those factors that make you not to go beyond a certain limit. And then we are putting non-negativity restrictions. Putting non-negativity restrictions. So those are the steps. So the first is you define the decision variables. So then decision variables, these are economic and physical quantities competing against each other for the scarce resources. So maybe you want to buy a pen and a book, and you feel like the pen, maybe you only have 20 shillings. So those variables are what you talk about in linear programming. So a pen and a pencil can be your decision variables. Then you formulate objective function. Objective function is what you want to achieve. Maybe you want to minimize cost, or you want to maximize revenue, or maximize profit. That can be objective function. Of course, then we have the putting or establishing the constraints. Then constraints are sets or conditions which solution must satisfy. There are a set of conditions which solution must satisfy. So maybe you can say like one pen, or maybe 2 pens, and maybe 3 books must not exceed maybe 50 shillings, or must not exceed 20 shillings. So those can be constraints. So if you have, in other words, for you to purchase these 2 pens and 3 books, their total cost must not exceed 50 shillings. That is in case of maximizing or constraint. Maybe sometimes you can be asked, maybe you need to supply maybe materials or maybe food. And this supply, you are asked that it must not go beyond a certain limit. It must not go beyond maybe a certain, you should not supply less than a certain level. So that can also be constraint. And then putting in a negativity. Of course, these constraints, you must not have a negative quantity, because we say that numerical values and are quantitative in nature. It's not possible to work with with the negative quantities. It's always positive. So that's why in any case you find that a variable is negative, ensure that you restrict it to be either 0 or greater than 0. So non-negativity non-negativity constraints can be maybe if there's a variable x, so x must be less than or equal to 0, or y must be less than or equal to 0. And even z, it is always the objective function must be less than or equal to 0. So you ensure that when you're going to solve it, especially when you're using graphical method, that those items that you find might appear on the negative axis, either on the negative side of the x-axis or the negative side of the y-axis. So in case you find that situation, know that you ignore those negative parts. That was the brief introduction to linear programming. What always now follows is the solution of linear programming problem. A solution of linear programming problem. And my students are having their graph books. These things, most of it you are done in high school. Linear programming. Was it in Form 4? Yeah, those who are friends of maths teachers. Now, so a solution of linear programming problem. You can solve it. The solution of LPP. I always call it LPP. The linear programming problem. So the first thing that we can check on is the graphical method. Graphical method. So graphical method is where you run using graph books, and everybody is having his or a pencil, because we don't draw graph using books. Using biro pens. So graphical method can only solve a problem that involves two unknowns or two variables, that is x and y, because you only have two axes, the x-axis and the y-axis. So the first step when you are running up a graphical method is convert the inequalities into equations. By the way, all this linear program always involve inequalities, so it can be 2x plus maybe 3y must be less than or maybe equal to 6. So you convert now those inequalities to equations by saying maybe become now 2x plus 3y is equals to 6. So convert that inequalities into equation. Inequalities means it's not equal. Maybe there can be surplus. Maybe this 2x plus 3y may not be 6, it may be 4. It's like if you have got, maybe you are buying something, and then whatever you have in your pocket is 50 shillings. So whatever you buy must, either they can be 50 shillings or less than 50 shillings. So you might find that there are some situations which we are going to discuss later, called the slacks and also the dual prices. So convert that into equation. Number 2, then plot. To plot graph of the boundary lines, you now plot it using the equations. I hope you remember how to run these ones. Maybe if you want to plot, remember you are having ranges, maybe x and y. So you can maybe arrange x when maybe x is 0. You look at how much y will be based on those inequalities or those equations that you have converted. So inequality into equations, of which now also then obtain the feasible region. So these ones I prefer that I explain them as we teach it. I'm going to explain it as we teach it. So there's a question here that I'm going to read for you. As I explain, then we go about it. So I'm going to read for those who are writing, for those who have written, or for those who have a question, then we are going to see how to plot it. If you guys are having a graph, a ruler, and a pencil. So they say Readymix Limited produces from two raw materials, M1 and M2. The following table provides basic data for the problem. So let me run that table. Let me run the table for you here. So the table looks like this. Tons of raw materials. So we have got exterior, and then we have interior, and then we have got daily maximum. Daily maximum. So raw material 1, exterior is 6, interior is 4, and then daily maximum is 24. Raw materials 2, exterior is 1, this is 2, then daily maximum is 6. Then there's profit. For exterior is 5, then for interior is 4. That's how the table looks like. That's how the table looks like. And then it continues and says, a market survey restricts daily demand to 2 tons of interior paints. Additionally, the daily demand of interior paint cannot exceed the exterior one by more than 1 ton. Let me repeat that. A market survey restricts the maximum daily demand to 2 tons of interior paints. Additionally, the daily demand of interior paint cannot exceed the exterior one by more than 1 ton. Then required, formulate the above problem as a linear programming problem. Formulate the above problem as a linear programming problem. And then B, using graphical method, determine the best product mix to give maximum profit. Using graphical method, determine the best product mix to give maximum profit. Good. So, in solving this thing, the first thing we look is how do we make this thing to be a linear programming problem? So, solution. We convert this into LPP. So, because I've said we restrict it, so we can say let exterior paint be X, and then interior paint be Y. So of course, then we are going to work with the coefficients of these raw materials plus the restriction. So when the exterior is 6, we can say 6x plus 4y. Then the maximum, they cannot exceed 24. So it can be less than or equal to 24 because they can't produce more than 24 tons. Another scenario here is 2x plus 1y, which is just plus y, must be less than or equal to 6. So those are the main decision variables. Those are the main decision variables in this case. Those are the main decision variables in this case. Then, having done that, then of course, they say that a market survey restricts that the daily demand to 2 tons of interior paint. So interior was Y, and then they say that the daily demand must not exceed 2. So then you can say Y must not be more than 2. So Y can be 2 or equal to 2. it continues and says that additionally, daily demand for interior paint cannot exceed exterior paint by 1. So interior was Y, cannot exceed exterior by 1 ton. So Y cannot exceed X by 1 ton. So that's how you write the inequality for that scenario. And then we are going to have also the non-negativity constraint, which you say X, Y, and Z must be greater than or equal to 0. Must be greater than or equal to 0. And then, of course, after writing that, then we have solved part A, which says that formulate the above problem as a linear programming problem. Formulate the above problem as a linear programming problem. So that's how you are to do it, the first step. And now, having done that now, if you come to part B, they say using graphical method, determine the best product mix to give maximum profit. So our objective function here, we always denote it by Z. So Z is equals to 5x plus 4y. 5x plus 4y. That becomes our objective function. 5x plus 4y. Good. So then we're going to have the graphical method now. We must find the coordinates of how we are going to plot it in a graph. You guys know how to obtain coordinates. So if you look at the coordinates of 6x plus 4y is less than or equal to 24. So you just run x and y like this. Then you say when x is 0 and 1. So x is an independent variable and y is a dependent variable. So you say when x is 0, y will be how much from this equation? Because we have now converted them into inequalities. We have converted the inequalities into equations. So when x is 0, of course here it will be 0 times 6, which is 0. And then it will now be 4 divided by 24. 24 divided by 4. 24 divided by 4 is 6, right? So y will be 6. When x is 1, it will be 1 times 6, which is 6. 6 times, 1 times 6 is 6. If you take 6 the other side, it will be 6. 24 minus 6 is 18. So 18 divided by 4. 4.5. 4.5. So already we have the coordinates for that one, which will help us to plot that graph. This one we can use a scale of 1 to 1. So I believe you have drawn your Cartesian plane. You still guys remember Cartesian plane? Cartesian plane used to look like this, or it used to look like this. This is y, this is x. So on your graph book, you plot a scale of 1, 2, 3. Let 1 centimeter represent 1, or 1 box represent 1 unit. 1, 2, 3, -1, -2, -3, and -1, -2, -3. So you draw it. Draw 1 to 1. 1 centimeter represent 1. So yeah, ensure that it's good. Ensure that those boxes will not go beyond 6, because we have a coordinate for 6 there. So you can try to ensure that your graph make sure that it's almost close to the margin. This thing should be close to the margin on the left, because we don't have any negative. Just take like 4, count 4, so you come this side. Yeah, then you can draw it. So you are plotting your graphs. So 1 centimeter to represent 1. Let me show you. So having drawn, I believe most of you have drawn.
Up to 6.
Up to 3 out of 10. So we are drawing graphs. We have set our scale 1 to 1, and then we can see that it's drawing. Good. So having drawn that, now we can plot the first one. Okay. The first one. So so you look at on the x-axis when x is 0, y is 6. So x is always 0 on the y-axis, right? So when x is 0, y is 6. X is 0 here. y is 6. So make a note at 6. And when x is 1, y is 4.5. So you look at 4, then the one that's katikati, additional 1. And then you join the straight line along those two the coordinates. So on your graph, and then name that one. Maybe I think it will appear like so maybe it's like here. So we have what? Let's say we have 6 here. 5, 4, 5, and then 6. So when x is 0, y is 6 here. When x is 1, this is 4.5 here. Then you draw a straight line joining them like this. Then you name that graph 6x plus 4y is less than or equal to 24. So having done that, we go and look the next coordinate. In our next inequality, it was 2x plus y is equals to 6. So again, we look at 2x plus y is equal to 6. So we run again that coordinate. Then you say x and y, 0 and 1. So when x is 0 here, of course y will be 6, because this will be 0. It has no effect even if it cross equal sign. So y will be 6. And when x is 1, y will be 5. So this will be 1, okay, no, not 5. 1 times 2 is 2. 2 minus 6 is 4. So again, the coordinates will be 0 and 6, and 1 and 4. So when x is when x is 0, when x is 0, y is, yeah, so on your graph, when x is 0, 6 still there. When y is 1, y is 4. So join them. 6. This is 2. X plus less than 6, right? Of course, we have not shaded it because this one. So this was list. The list was it was supposed to exceed 24. So it was either less than or equal to 24. So above here is above 24. So we shade it. We don't want it. So we shade the upper region that we don't need it. Then the other one we are told is 6 and 4. So 6, maybe 4 here. So again, because okay, your graph is okay, mine is just a rough test. We draw the upper part because they were limited to. You shade the upper part because they were limited to 24. Again, we go to the next coordinate. Y is equals to 2. Y is equal to 2. Y is equals to 2. You know just that 2 will be here. So y is, there's no x. Y is less than or equal to 2. So this should just be 2 here. You just run a straight line where y is equals to 2. And of course, it must not exceed 2. So you shade the upper side like that. So we are remaining with the last variable. The last variable, the coordinate is y minus x is equal to 1. Y minus x is equals to 1. So if you run those coordinates, this is x and this is y. So 0 and 1. When x is 0, be 0 times negative 1. With 0 times, it will be just 0. And then y will be 1. When x is 1, it will be negative 1. Negative 1, if it goes the other side, it will be positive 1. So 1 plus 1 is 2. So again, we are going to have when x is 0 here, y is 1. So y is 1 here, put a dot where 1 is. And when x is 1, when x is 1, maybe 1 here, y is 2. So 2 should be here. Y is 2. Then you join them like that. So this should be y minus x is less than or equal to 1. So of course again you shade the upper side because it was a minimizing problem. This one. This is 2. minus x equal to 1. Is less than 1. Okay, so we have, because of course we didn't want it to exceed 1, you shade the upper side. So we have got 3 corners here. We have 3. How many corners? Are there 5? There is, of course, okay, before we look at the corners, we shade the non-negativity. So anything negative, this side y is negative. So we don't want it. And also this side x is negative, we don't want it. And this side the same. Anything negative we don't want. So our region here is 1, 2, 3, and 4. Those corners. So you can call them corner A, B, C, and D. There are A, B, C, D. Are they 4 or 5 according to yours? Those who have drawn it. How many corners are they? The 5, right? Anything negative side, remove. So you can see there, you can name those coordinates. This can be A, 0, 0. So there are 5 corners. If you draw it, you're going to find 5 corners. So that's why we are going to, those are the coordinates we are going to use to subject our objective function. So I'm rubbing it, I'm relying on, I have a student here who has used her graph book. So I'm going to rely on her coordinates. So where we had got, you can write points, and then x, y, their objective function 5x plus 4y. So the one that will be maximum, that is where we are going to have. So she's telling me our points are 5, A, B, C, D, and E. So with your points, so at point A, on your coordinates, Ax is 0 and y is 0, right? So right here, 0, 0. And then you come and write 5 times 0 plus 4 times 0, which is 0. So the profit at that point is 0. The next point, I'll still rely on your work. Point B, x was how much? X was what? X was 0 and y is 1. This y-axis, x is 0. So x is 0, then this 1, because right now x is 0 for 1, 2. So because when is 0. So 0 and 1. So there's 0 and 1. So this will be 5 times 0 plus 4 times 1, which is 4, right? The next one, C, y is, x is how much? X is 1. X is 1, and this is 2. So this will be 5 times 1 plus 4 into 2. This is giving us, this is 8. 8 plus 5 is 13. D, point D. So it's 2 and 3. 2 and 3. This will be 5 into 2 plus 4 into 3. This is 10. 10 plus 8 is 28.
10 plus 8.
10 plus 12 is 20. No, 22. This is 10, this is 12, right?
Yes,
22. And then the last one.
X is 3.
Y is 0. Y is 0 at x. At x axis, y is 0. At x axis, y is 0. At y axis, x is 0. So if that coordinate falls on x axis, maybe it can fall on 3, on 6,
It's
on
on
x.
3. On X axis, it's on 3.
Then that means y is 0 at that point.
Oh, yeah, because we didn't go beyond.
Yeah, because y starts 1 in line now. So coming up, 0, 1, 2. So if you line by line, y is 0. 0 becomes 1. Another negative. So if you land on this line, that line, and that center, it will be 0.
Meaning kilat.
Where there's a some coordinate coordinate on this line. So you find that come out on as a pattern, x is 6, but y is 0, because y1 is 0. So you need 1, y2. Again, come on up. If x is 0, if let's at maybe at 4 here, at 4, when y is 4, x is 0. Ila inyo x is 0 because that 1 x is 0. 2 kuja tu. So ikiwa tukimia na hii line, everything ya x is 0. So then ikienda hizi x is negative. So at that point where there is this intersection between those axes, x is 0.
Now see, we are following these coordinates.
So now in this case,
3.
X is 3, y is 0. At that point.
Because we don't need this part.
No, but we don't need this part. That is where the corner is. This area in the front of the here behind the physical region.
So we work
Then
within
shaded
the
area. Then shaded area.
So
umeshare vitu nje. So hapo katikati ndio tunataka. Aya. So we are going to have 5 times 3 plus 4 times 0 is 15. So if they ask you the maximum profit is maximum when x is 2 and y is 3. X is 2 and y 3. This thing can vary based on the scale you have chosen to use. There can be slight difference because of the scale you choose to plot your graph. But the examiner knows that if it follows your instruction, then he will fine. So for this boat to maximize profit, they need to produce 2 tons of, 2 tons of exterior paint and 3 tons of interior paint to maximize profit. Then to maximize profit, you produce, because X was exterior, right? X was exterior paint and Y was interior paint. So to maximize profit, they need to produce 2 tons of exterior paints and 3 tons of interior paint. So it wasn't that challenging. So that's how you are to solve that graphically. So we'll do another question another time, and then we later solve another scenario where you can be asked to solve linear programming involving more than 2 unknowns in a method we're going to call it simplex method in solving linear programming. So for this session, for this live session, we can put it at end at that point on how to plot graphs. So ensure that you get familiar with graphical plotting. So until we meet another time, bye for now.